Good morning, student. Today topic is moment of inertia of a continuous body. What is continuous body? Continuous body in which mass is distributed continuously. For example, rod, disc, sphere are the example of continuous body. Suppose this line is axis of rotation and in front of it a rigid body is placed. We are going to find the moment of inertia of this continuous body about the axis of rotation. We consider a dm mass which is at a distance of r. This r is a perpendicular distance between axis of rotation and dm. In this case, small d I is equal to dm r. If we integrate both sides, then di is equal to integration dm r square. Integration of di becomes I, total moment of inertia dm r. We remember where r is perpendicular distance between axis of rotation and dm. So using this formula we are going to find moment of inertia of a uniform. So heading is moment of inertia of a uniform rod. Uniform rod means in a uniform rod mass is distributed uniformly. Rod is also one dimensional body. So we first take axis of rotation and there is a rod of length L and mass M is placed like this, and we have to find moment of inertia of this rod about this axis of rotation. At a distance x, we consider a small strip which has length dx, and the mass of dx strip we consider dm. So according to the definition of moment of inertia of continuous body, moment of inertia of this rod is equal to dm x square. We have to put the value of dm. We know that mass equal to linear density into length. Linear density is denoted by lambda. Linear density is equal to mass upon length. So linear density of this rod is total mass upon total length. So dm mass, from this formula, dm mass is equal to linear density lambda. Length of this strip is dx. So we have find the value of dm. Now we put the value of dm in equation 1. Then from equation 1, I equal to integration the value of dm lambda dx x square. lambda is equal to m by l. So I equal to integration m by l dx x square. M by l is a constant term, so we take it out from the integration. So m by l integration x square dx. At the initial point the value of x is 0, at the end point of the rod x value is l. So limit of x is from 0 to l. We put the value of limit of x 0 to l, and after integration of x square we will get x to the power 2 plus 1 upon 2 plus 1 limit 0 to. So m by l x to the power 3 divided by 3, x to the power 3 divided by 3, and its limit is 0 to l. Now we put the value of l and 0, then integration, then moment of inertia m by l to the power 3 divided by 3 minus 0 to the power 3 divided by 3. 0 to the power 3 becomes 0, and we get I equal to m l to the power 3 by l. One l is cancelled, and we get I equal to m l square by l. So students, by this way we can easily find the value of moment of inertia of the rod when axis is passing from the one end of the rod. Now we will do another moment of inertia. So another heading is moment of inertia of a rod when axis is passing through midpoint of uniform rod. So in this case, the axis of rotation is passing through the midpoint of the rod. We make a rod. Suppose this is the midpoint, so axis is passing through the midpoint. At a distance of x, we consider a small strip dx which have mass d. The length of we are going to find the moment of inertia of rod when axis is passing through the midpoint of a uniform rod. Here again the total length of the rod is L, total mass is M, so half length is L by 2 and half length is L by 2. And total mass of the rod is M. We consider right side portion positive length and left side portion negative length. So value of x here minus L by 2 and here x equal to plus L by 2. And the mass